Almost half the plastics that we use are thrown away after just a single use. The problem is, there is no away, and plastics can take hundreds of years to degrade, so every single piece of plastic disposed in our red or yellow bins that has not been recycled still exists. We live in an age of plastic. Polypropylene is in margarine tubs and even fibers in carpets. Polystyrene is in building insulation and protective packaging. We find polyethylene in anything, from plastic balls to bin liners. They all have one thing in common: they were once oil. A mix of chains of carbon and hydrogen, which all have different properties depending on their structure. Some of this waste can be recycled into new products, but most of it, known as end-use plastic, currently has no second life and ends up in landfill, where it can release hazardous chemicals into the environment. The solution? Polymer energy. Without the need for source segregation, washing, or drying of post-consumer and industrial mixed plastic waste, this plastic waste are packed into large bags, loaded onto a truck and sent to the plant for processing into polymer oil. Post-consumer plastic wastes are loaded onto a conveyor belt and fed through a rotary trommel in a sort of large jumbo bags, baled and stocked, awaiting the next step in the process. The bales are fed into the loading press. From here, high-pressure hydraulic cylinders push the plastic into the reactor. This is the heartbeat of the process. Through multiple temperature zones, the extreme heat inside the reactor melts and vaporizes the plastic. The key point is, with transverse flow catalytic conversion technology, the molecular bonds of the long carbon chains that make the plastic what it is break apart, returning them to the various small hydrocarbon chains that they were created from in the first place. The resulting hot vapors are condensed into liquid form, creating high-quality, sulfur-free polymer oil, which is sold in tankers to industries such as Unilever and Britannia. Further value can be achieved by increasing production volumes and separating the polymer oil into various hydrocarbon fractions, such as jet fuel, petrol, diesel, kerosene, and furnace oil. This robust technology is energy efficient and self-sustaining. When plastic is cracked, non-condensable gases, methane, ethane, propane, and butane, are fed back into the reactor and completely used as a fuel. This technically competent process is fully automated and operated through computerized controls from a PLC panel. The plant processes on average an impressive 10 tons per day of post-consumer and industrial waste. There are no effluents and no waste or pollution generated from this process. With 500,000 tons of plastic going to landfills every year in Australia alone, there isn't a shortage of raw materials, but the political and consumer mindsets need to catch up. The vast majority of plastic waste is still not yet recycled. Society and industry should look at end-to-life plastics not as a waste, but as a product that has value and something that does have use.